Good. You are welcome back to our session with me, Edu Ada. Today we'll talk about length of a chord. We've mentioned about the different properties of a circle, and one of them is also a chord. So as we take them bit by bit, take note of these properties and their own function in relation to their formulas for solving questions on them. So you have a circle again. You have this circle. Just manage this, and you have it to be having a radius, this and that radius. And another line is drawn here. This particular line, it is called the what? It is called the chord. And that's what we are dealing with right away. So if you have this radius, it has a length, just a length. So how do we calculate the length of the chord? How do we go about the calculation of the length of a chord? You may not need a formula for it. Yes, you may just calculate. Look at this. This is theta. Lay this down. Then you find this place will be half theta. This one will be half theta. This is theta upon 2. This one too is theta upon 2. I mean the two angles. So bro, then give you theta. So there you can relate it. If you are giving this side with respect to this radius, you are good to go. But let me give you the formula for the length of a chord. The length of a chord, let me call this A, let me call this B. So the length of a chord will be equal to, you have 2r sine half theta. 2r sine half theta. What are you considering there? So you have like AB sine theta, where AB is, okay, it's not, because if you have AB, you have R times R. But here it is R plus R, then sine half theta. Let's work with that and let's solve a question on that. So we have the question before us. The question says that the angle subtended at the center of a chord. So I will still have to draw a circle. Okay, same shape. This is the angle they are talking about. This is 120. 120 degrees. Radius 6 centimeter. This is 6. This is 6. You are looking for this. I'll call it L. Find the length of the chord. Don't simple, straightforward, like we've done before. Number 1. Our L is what? The length of chord. Length, not length of arc now. The length permits me to use L of, name this AB. Yes, name this AB. Name this AB. You have your A here, you have your B here. Length of AB, or I just write my AB can be equal to 2R sine half theta. And how do I get over this? Or how do I get this done? All I have to do to write it out, so this can be equal to 2 times my radius. The radius is 6 centimeter plus, okay, sorry, you have still times, have times, then sine, open a bracket, our theta is 120 divided by 2. So then that eventually becomes 12 sine 60 degrees. What is sine 60 degrees? Punch your calculator. So you have 12 times, or if you have an idea of this trigonometry, um, the sine and cosine or tan trigonometry of what? Angles less than 180. So if you have something like this, you have something like this, you have something like this. I take this to be 60, take this to be 30. Sine 30, I know opposite of hypotenuse is half. So this last angle is root 3, which means sine 60 opposite of hypotenuse, that will be equal to root 3 upon 2. So this is root 3 upon 2. So 2 here 1, 1, 2 here 6. The final answer is 6 root 3. That's the length AB. If you are told to leave your answer in short form, and if not, just multiply that, so you have 10.39. That will be in centimeters. So you have that, this in centimeters. That is sorted already. So quickly, we go to the next question. And the next question is talking about the what? It is talking about, the next question is talking about a chord also. So here it says, question 2. A chord of a circle 8 centimeter long. Okay, let me draw the circle. Each is a circle. This is a radius. It is 8. Permit me to have something bigger. Something like this, something like this. This is 8 centimeters long. Subtend an angle of 120 degrees at the center. Find the radius. You are looking for this. So how do we go? Since we know it is the length of arc that has been given, you cannot go and work with sector. You cannot work with area of a circle. So you should know that this will involve the length of Okay, let me note this. This is A, this is B. So since we know that this length AB is equal to 2r sine half theta. So you go wipe this off and you go, what do you have? Length AB becomes what? Our length AB has been given us 8 centimeters, so you can impute it right away. That can be equal to 2 times your R, which we don't know, then times sine half of the angle we are given. What's the angle given? 120 degrees. Sine 60. So 8 is equal to 2R times sine 60, we did it the other time, is root 3 upon 2. So what do we have? This cancel out this. So automatically R becomes 8 divided by root 3. This will be the length, or the length of your radius, which will be in centimeters. You can re-express it in decimal, your 8 divided by root 3. That becomes 4.62 centimeters. Thank you for staying with me. You can solve this third question. You can solve this. With the knowledge of what we have done, you will get it done. Thank you. See some other time.